What you are going to study now is what you will be studying in 11. The chapter's name will be Atomic Chemistry. Same thing, advanced, don't yawn. Atomic chemistry, you will be studying the same things but with mathematical problem doings and calculation. What you study in grade 11 in atomic chemistry is line by line same in grade 12 physics called modern physics. Modern physics is atomic physics. They are exactly same. You will be learning about the electron, proton, neutrons, all these things even in grade 12. And grade 12, 11, so if you study good in 11, then automatically 12, just preserve those notes. You can study from those notes and you can do it. Okay, there are two chapters in modern chemistry called atoms and nuclei, and there's one more chapter. So both actually merge with atomic chemistry. Okay, what we are going to study now is Journey Inside the Atom, which is a prelude. So 10th, you will not study all these things. Okay, you will be studying these things again in 11. Now, your NCERT book deals it in a manner, but since this is the love for atomic chemistry, if you want to develop it, you have to first appreciate where we are, what is happening. Okay, all of you must have heard about this Renaissance period, the Industrial Revolution and all. Okay, whenever war happens, science sees the maximum amount of advance and development. Okay, but today you think of anything in and around you, you think of right from the motorcycle to the machine gun to the safety razor to the projector to the camera, everything is during the Second World War period. Everything, the tank, the fighter aircraft, whatever you think, because that time industrialization goes on a rampant mode. And if you look by geography, in both the wars have been fought on the European front. America was untouched. And America at that time, just after 100 years of independence and all, used to have a lot of invite people as migrants who used to come up and make America a great country. So there was a lot of industries which were set up in America. Earlier, all these industries were more in Britain and Germany. The brains in this world, as they say after World War II, the brains and the inventions are always with the Germans. Nobody can compete with them in terms of engineering and technology. After Germany's loss in Second World War, these are quoted, unquoted. It says, America took away all the people, the good people migrated to America. And Russia took away all the documentation, and Russia documented everything, all these in Russian. That's why India, who shares a good relation with Russia, should know that when we do engineering drawings, we say ASME standards, American Society of Mechanical Engineers. The whole world follows one drawing standard. Russia follows one different drawing standards. So if you are an engineer who can read Russian drawing, your valuation is much, much high. Means you know how to read that drawing. It's a completely codified way that they. So all these developments come from actually the later part of Germany. So in Germany, you should understand, you had the Nazis who used to be ruthless upon the Jews. So all the Jews, Otto Hahn, the man who made atom bomb, he's also a Jew. So they all found place in America at that time, because in this part of the geography, they did not have people who would to listen to them. And what you read, so if you develop knowledge about world history, you get to know what you read is only the goody-goody part. There are bad parts also. There are parts in which mankind has been destroyed, distracted. Like there is a person called Fritz Haber. Fritz Haber is a German who is known for the discovery of the industrial process of ammonia. But Fritz Haber made everything which was used for destruction of mankind. His gases were used for killing people in gas chambers, so much so that his wife also left him. But last में जिंदगी बड़ा खराब हो जाता है इनका. Their life becomes like shattered life. Then all these experiments were carried up on all the, you all know these detention camps. Are you familiar with World War II history? There's a place in Poland called Auschwitz. Okay, so Auschwitz is a detention camp. Then Sobibor, then Treblinka, Belzec. These are places where on people all these druggings and all these experiments were actually carried out. So even those doctors and engineers were later hanged by the military court after the war, because they used to do ruthless things. What you read is only the good part of science. Okay? So this chapter is all about the journey inside atom, and we have to take ourselves back in the era of 1880 onwards. Till now, man knows about electricity, but man does not know about electrons carry electricity. Okay? Man knows about electricity, and electric light is already there. The generator is also working, but you do not know what is inside the atom, right? So we start. It's like a story. So unless and until you understand, take interest, आपको मजा नहीं आएगा. So the first thing when we look at atom, and I go back to my same drawing, and I say that we had what, a black forest cake. Okay, a black forest cake, and a black forest cake is known as a piece of matter. Matter. Anything that occupies space, has mass, and can be felt is called a matter. A black forest cake has mass, black forest cake occupies space. But if it was air, then you can't see air. Therefore, we add that third component called can be felt. If you can feel it, then it's matter. Now, when we break it down finally, then we come at a atomic level. All right. By now you know everything, that this is in the standard of chemistry. I'll call it as what? Impure substance. Yes or no? Yes. And if it is an impure substance, it has to be some sort of a mixture. And if it is some sort of a mixture, it must be having many compounds, right? Many mixtures also, end of the day, and many elements which are actually mixed in some proportion which are not definite. And if you are a compound, then you are also comprised of many elements, end of the day. Elements. And all these elements, finally, you can come down to atomic level. Have you understood? Let's say, to make this black forest cake, we must have used something called sugar. So if you look at sugar's molecular formula, C12H22O11, which means that you have carbon, you have hydrogen, you have oxygen. So these are all the atoms which are present, and we come down at the atomic level. This story is all about atomic level, that we will be going inside the atom for the discovery of subatomic particles. So are we ready? This is just the start. Okay, so our discussion starts from discovery of the first subatomic particle, which is known as discovery of electron. Discovery of electron. As of now, what is our knowledge? We know electron is a negatively charged particle. Electron has some charge, electron has some mass. First, get some myths cleared from you. Electron is such a light particle that you cannot actually consider it as a particle. It is almost taken to be like a wave. You don't see it. It just leaves an impression. Wear a white collared shirt and roam the whole day and come back and you see your collar, you have got a dust mark on your collar. Did you see those dust particles? No. They left some impression on your collar. So the electron, when you say electron microscope, you don't see electrons moving like that. They will be leaving their impression and going ahead. Okay. So the discovery of electron is actually attributed to an experiment which is known as the cathode ray experiment. Cathode ray experiment. The cathode ray experiment happened in something which is known as a cathode ray tube. So maybe nowadays you see televisions which are flat back. If you see, go back 10 years, 15 years back, you would see computer monitors which did not have a flat back, or televisions which did not have a flat back. Have you seen a television without a flat back? Right? Those used to have a picture tube. So those monitors, when those monitors were prevalent, we used to say, "Arey, he has got a 14-inch CRT monitor." CRT means cathode ray tube. So it's basically a cathode ray tube. So in your television screen, the televisions which we have seen in our childhood, these are LED screens. Then came, it used to be cathode ray, then came LCD, then came LED. Plasma screens were there, which did not pick up that much market. So nowadays, every screen you see is an LED screen. The screen has millions of LED pixels on that. More the number of pixels, greater the clarity. Before that, we had LCD. LCD is something like, LCD screen is, this is LCD screen, liquid crystal display. And before that, we had was cathode ray tube, high voltage cathode ray tubes, where actually rays will go and impinge on them. This story's experiment also happens in a tube like this, which is known as the cathode ray tube. इसको थोड़ा detail में देखते हैं. So how was the cathode ray tube designed? Okay. So I'm making some freehand drawing. So let's see. So the cathode ray tube was a tube like this, okay, and this is a standard formation of a cathode ray tube. The tube will have gas or air, and the air will be at a very low pressure. So you will have air at very low pressure. That means this is connected to a vacuum pump. You know what is a vacuum pump? An air compressor is something which will blow air. A vacuum pump is suck out. So all the airs are sucked out. So if you suck out, then what is remaining here? Air at a very low pressure, because if there is no air, there cannot be any pressure, right? Then there are two electrodes out here. One electrode and another electrode. They are pieces of metals, okay? And these electrodes are actually connected to, to direct current, high voltage, very high voltage, DC, direct current. Okay. And from there, the magic will start. The one that is connected to the negative terminal, this terminal is known as cathode. Right? And the one that is connected to the positive is known as the anode. If you have any difficulty, always remember CN Cartoon Network, or you say, don't panic. Positive is anode. Panic, P-A-N-I-C. Negative is cathode. Okay, fine. And high voltage was given. At that time, we also use a material which you will hear a lot, which is known as zinc sulfide. Zinc sulfide in all these is used as a screen layer. Screen. Zinc sulfide is fluorescent in nature. Fluorescent, when some particle strikes it, you will see fluorescence in it. Right? Means this portion is coated with zinc sulfide. So they will do a light coating of zinc sulfide out here. Light coating of zinc sulfide. The zinc sulfide coating. And zinc sulfide is sensitive to particle hit. Once a particle hits, there is a fluorescence in there. You can understand that something has come. And this setup and experiment on all of these things is actually attributed to the person named J.J. Thomson. Year is around 1897. Okay. So J.J. Thomson found that when this setup was done, there was a glow that was observed behind the anode. Sunde jao abhi maze se. There was a glow that was observed behind the anode, right? And then question came up. Well, we are discussing it in a very, very high level. So the glow was observed. So where did this glow come from, right? So a lot of experiments were done, out of which 2 or 3 we will see. So he attributed this glow to be something called rays which actually travel from the cathode. There were some rays which travel from the cathode, and these rays actually went and struck this zinc sulfide screen, causing fluorescence out on this side. Okay. Now, are these rays or are these particles? Okay. So from this side, what came? Cathode rays. Cathode rays. Now the question is, did this cathode rays comprise of particles? When do you call something particles? I call something particles when they have got mass associated with them. Mass. And if you have mass in something and it is moving, then it is carrying what? Kinetic energy with it, half mv square. Kinetic energy is the energy possessed due to velocity, right? Possessed in motion. So if this was cathode rays, who are these cathode rays? The question came because the rays were coming up from the cathode side, and these rays were actually creating a fluorescence or a glow on this side. So they said, the question came that are these rays some particles? So some experiments were done. Okay, so I'm now just rubbing up a portion of it. The experiments that were done were, the first experiment was done is that very light pedal wheels were kept in its path. Pedal wheel. These all are there, not in your textbook. Pedal wheels were come. When the rays used to impinge on them, the pedal wheels used to rotate. That means transfer of momentum is taking place. When you transfer momentum, you transfer force. So who can transfer momentum? A body who has got mass with him. So these rays were actually called that these are rays, but they are actually particles. One thing is, so these particles are associated with some sort of a one parameter, which we say is mass. The question arises, if they are moving from negative to the positive side, that means they have an affinity to go towards the positive side. So the particles must be negatively charged, but you have to prove this also, whether the particles were positively charged or negatively charged. So actually what happens when high voltage is applied, the negative side, which is, this is the negative side and this is the positive side. Later you will also study about X-rays. The negative side will repel the electrons out from here. Now still now we don't know the word electron because we are in 1897. We just saw that some sort of rays have traveling. So what they did next they brought electrical field in the vicinity of this tube. So there was a strong electrical field created, a positive side and a negative side. When they did this, they means J.J. Thomson, he found that the rays started to move towards the positive side. Who moves towards the positive side? Someone who should be negatively charged. Otherwise, you should have not moved towards the positive side. So first finding was, if you put a paddle wheel, it actually rotates. That means these particles, these rays are actually particles, a stream of particles who have mass in them. Then they are negatively charged. The second thing that they did was, they brought magnetic field in nearby. Now this you will not understand now. Magnetic field means one side they put say North Pole and one side they put South Pole. Then also there was a movement. Now whichever side it moves, that shows that it is negatively charged. That is in grade 10 we will learn. That is something called Fleming's left hand rule. In grade 10 we have it. So how do you know that they are negatively charged? Because their movement was to that pole where a negatively charged particle will move. Now three observations we have come across from J.J. Thomson's experiment, that whatever is cathode rays, whatever was cathode rays number one, originate from cathode. Okay, these questions might be asked to you. Travel towards anode. Then what is their electrical polarity? Negatively charged. Okay, and they also contain mass. So that means you have to attribute the word particle to them. Now the next check. Is this fundamental or is this different? Like if I make a small slit in your skin, you will bleed. If I make a slit in somebody else's skin also, you will bleed. And if we observe the blood chemically, then we find that blood is something which is fundamental to us as human beings, one form of mammals. Okay, so is this a fundamental particle? So the next thing what J.J. Thomson did, he changed the material of these electrodes and he took different gases. So in higher chemistry we say he used to conduct something which is known as E by M ratio. Just understand it so that in grade 11 this is not Latin for you. E by M means charge by mass. E is known as the charge by mass ratio. So when he conducted this experiment with different type of gases, he found that the E by M ratio is always constant. So do you understand the meaning of that? That means the particles which are emitted is the same particle emitted irrespective of what type of gas you are actually using. And then he coined this as what? He used the word electron. The first subatomic particle that was known to man. In the year 1897, J.J. Thomson is attributed with his discovery. Now, there are a lot of, we only read one part of it, but those days you did not have Google, you did not have something to check plagiarism and all. It's not that only one person is doing this test. Telephone and internet is not there. Who knows that there are many experiments which are being done. Actually, in India, there were many experiments also done. The only thing is that the attributing the thing. Radio is actually from India, but it's attributed to Marconi. Radio's actual invention goes to Jagdish Chandra Bose. That's why that music company Bose is honored in his name. Americans did it. We Indians never did. So there have been three great scientists of those days. Meghnad Saha is one of the scientists whose works were even taken up by Einstein. But the only thing is that our country was not independent at that time, right? So the astronomical calculations were far, far ahead. Even people like Ramanujam were also not supported from people from India itself. So J.J. Thomson is attributed with the discovery of electron. Year is 1897. The discovery of electron is attributed to cathode ray experiment. What is a cathode ray experiment? A tube is taken up which is evacuated with air at a very low pressure with two electrodes. The negative electrode being named as the cathode electrode and the positive as the anode. And a layer of zinc sulfide was put on it. Why zinc sulfide? Because if you see any particle impinging on it, zinc sulfide will start to glow, which will actually tell you that there are some rays which are traveling. These are invisible rays, and you used to see a glow on this side, and this glow was known as the anode glow because the glow is happening on the anode side. Okay, these rays were tested for their mass. How? By putting pedal wheels. These rays could have capability to turn pedals, very, very small, tiny pedals, which actually proved the fact that they contained mass. They had momentum with them. The rays used to bend towards the positive side of any external electric field kept, supporting that they are negative in nature. Then course of travel was also bent by strong magnetic field, and the direction to which they bent proved that they were negative in charge. So the conclusion was that cathode rays originate from the cathode, travel towards the anode, are negatively charged, have a mass. So they were called as particles. And these cathode rays were said to be comprising of particles which were electrons and were fundamental. Why fundamental? Because when the gas was changed or the plates were changed, this observation was found. And in this observation at a higher level, they used to do something called charge by mass ratio. It's called Millikan's oil drop experiment. The charge by mass ratio always remained constant. In your book, it will be in just one small paragraph that J.J. Thomson did this glow and this was electron. Otherwise, you will not appreciate the proton part. So this is any questions here you want to ask. So this is the discovery of electron. What is now important for you is that after this discovery, J.J. Thomson gave his model. His model was known as the plum and the pudding model. Plum and the pudding model. Okay. Before the plum and the pudding model, let us also try to understand the watermelon structure. The watermelon structure. Okay. Now the atom is electrically neutral. The atom is electrically neutral. Okay. So the plum and the pudding model says that, let's first understand the watermelon structure. So suppose this is a cut piece of a watermelon, and what is the color that you will see usually? Say red. Okay, you'll see a red color inside it, and then you will see some seeds, watermelon seeds also. The seeds will be black in color. I can't use black, you won't be able to appreciate. So we will use some, not white, some blue colors we will use. Okay, these are showing the seeds. Okay, now we'll come to this model a little bit later. Just keep this drawing in your mind. Now the atom is said to be electrically neutral, right? The atom is, now see, everyone is not so clear in their intent. The atom, will come to this slide little 1 minute later. Okay, now J.J. Thomson had an issue. So let's see what he did. Our friend J.J. Thomson. J.J. Thomson said that it was known that the atom is electrically neutral. So if the atom is electrically neutral and you have discovered, by 1897, what did you discover? By 1897, you have discovered something called cathode rays. And cathode rays, the name given was electron. For this, he has Nobel Prize also. Now this man starts to think if there are cathode rays, there should be a positive particle also. Otherwise, how the atom is electrically neutral? So he conducts similar experiments also. And if you read, there is a lot of controversy here. Around 1917 to 1918, the word is coined for something which is known as proton to be another positively charged particle which is there inside the atom. Proton name is given by J.J. Thomson, and he wants to proclaim its discovery also. However, back in 1886, I think 1883 or 1886, there is a German person whose name is Eugen Goldstein. Eugen Goldstein had, do you know the word serendipity? Okay, serendipity is when you want to study for something and you accidentally discover something which is much more important than what you are studying. Penicillin, you know, penicillin. Alexander Fleming's penicillin discovery is a serendipity. You are studying for something and you found the Ajanta Ellora's discovery. It's like serendipity. You were studying for something and you excavated something different, okay? And that something different creates much more importance. So in the year 1886, Eugen Goldstein is a German person, okay? He's a German scientist, and he had no intention of these subatomic particles and all. He was doing some experiment on something which is known as anode rays, basically to build up something like a television monitor or an oscilloscope. Anode rays. Later, these rays were also called as canal rays. Sorry, C-A-N-N-A-L. Canal rays. So the body, the scientific body, did not attribute its discovery to J.J. Thomson. J.J. Thomson, dono le lena tha. Are you understanding? But this fellow discovered anode rays in 1886, whereas electrons were discovered in 1897. Just that he did not coin them as what? Protons or something. But his experimental setup was much before that. So this attribution is not given. Many American books will write protons discovery is J.J. Thomson. Protons discovery is not J.J. Thomson. Eugen Goldstein is the person who has discovered it. The documentation of the word proton was not there. So what was that all about? That had same sort of a setup, right? There will be a cathode, there will be an anode, and he used to study same high voltage, and we will have positive connected on this side. So this will be known as my cathode, and this will be known as my anode. Which one? Sorry. Yeah. So this is my, thank you. Sorry. So this is the negative side, which is known as the cathode, and this is positive side. Okay. When he was doing his experiment, he was doing it with hydrogen or say helium at low pressure. So that means here also evacuation is taking place, right? And the cathode was actually perforated. Do you know what is perforated? Like the shower head, have you seen? It has got holes inside it. Perforated. Perforated is when you have holes inside it. So while they saw that there was, now this experimental setup is exactly same as cathode ray tube. In cathode ray, instead of gas, air was taken. And when we used to change these materials and all, we used to find the E by M ratio same. Whereas in this setup, what he did, he took hydrogen. Now this is happening in 1883, okay? 1883 to 1886, okay? Around, I might be wrong, 83 or 86, okay? So while there was a glow seen on this side, there was a glow, reddish glow, which was also seen on this side. There was a reddish glow which was also seen on this side. Question is, there must also be some rays which are traveling from this side to this side. His idea was to build up a viewing tube. He had no idea of making any electron, but when this fellow started claiming for proton, it was seen that this study has already been done. And he documented anode rays very nicely. So what did he do? In those days also, same pedal wheel was kept. They could rotate the pedal wheel, so they had mass. Now just see, anode rays में कुछ interesting findings हमें मिलेंगे. Anode rays. The anode rays also had mass. The anode rays were positively charged. Okay, they were positively charged. Then they were also deflected by magnetic field. which made it clear that they were positively charged. Okay, and yeah, positively charged mass, and they travel from anode to cathode. Now there is this thing. Many children think anode rays are protons. Anode rays are not protons. Anode rays are not protons. They were not documented as protons for a particular reason. When you are changing the gas here or the plates, in this case, the charge by mass ratio changes. Mass ratio changes, which means that for different gases, though you are getting a glow, you cannot point that particle to be same as the particle for the previous gas. So question is, what are these anode rays end of the day? So these anode rays are, see what happens, there used to be atoms of the gases out here. Atoms of the gases. These are the atoms of whatever hydrogen gas or helium gas that you have taken. When you apply high voltage, then cathode rays will be moving, which we have just discussed. What are cathode rays? Cathode rays are electrons which are moving. These electrons at a very high speed will knock out the electron from this particular atom. As a result, the atom becomes what? Positively charged. Have you understood? This electron is knocked out and it becomes positively charged. So we say that this particular gas has been ionized. Ionized. So anode rays or canal rays are a stream of ionized particles which are moving from anode to cathode. And as you are changing the gas, the charge by mass ratio is changing. Now the question is, how did we then link it with protons? Anode rays will be protons if the gas is hydrogen. Why? Look at the hydrogen atom. Hydrogen has got one electron and one proton. Very interesting. If you strike out this electron with a cathode ray electron, what is left? One proton. Hydrogen becomes hydrogen ion and loses one electron. We don't show, in chemistry we never show negative. You understood this? Hydrogen becomes hydrogen ion. समझ में आ रहा है कि नहीं? By losing one electron. What is a hydrogen ion? A hydrogen ion is a proton. Just think, hydrogen in its atomic state has one proton and one electron. You have pilfered the electron. So what is left? Proton. So this question is often asked in interviews also. Are anode rays protons? No. Then why did people glorify Eugen Goldstein with proton? Anode rays are protons only if the gas taken is hydrogen, not even helium. Hydrogen. Because in hydrogen there is only one electron and one proton. So if an ion of hydrogen is moving, it is nothing else but proton. This is the discovery of proton. The word was coined back in 1917 or 18, but the study was done long back. So every book of chemistry starts with the discovery of electron, whereas by calendar, the discovery of proton precedes the discovery of. Yes, चीज समझ में आया? एक बार फिर देखते हैं. So before understanding proton, I am J.J. Thomson, and I have just discovered electron. But I know that the atom is electronically stable. That means, or electrically stable or electrically neutral. So if I have got negatively charged particles inside my atom, there has to be positively charged particles also. So let us begin the hunt for those positively charged particles. How did I discover the negatively charged particles? By cathode rays. Can we create a similar setup and find some anode rays, that is illumination on this side? So yes, he was doing some setup and he found some illumination, and that took him from 1897 to another 20 years. But when the proclamation was made, it was actually found that the anode ray study has been done long back. So many books will say proton discoveries to Eugen Goldstein, but Eugen Goldstein did not term the word proton. He just did the experiments on anode rays, reh gaya, and he was doing something different. This work will become something big. That was realized later, and this fellow coined the term as protons. Understood? So if we look at the two type of rays, The electrons or the cathode rays travel from cathode to anode, negative to positive. Anode rays travel from positive to negative. They are actually a stream of particles called electrons. They are a stream of ionized gases. They become protons only when the gas is hydrogen. Both have mass associated with them. The mass of electrons are also capable of rotating pedals. The mass of protons are also capable of. Both get deflected by an external electric field. Both get deflected by an external magnetic field. But the difference is, when you see an electron or a cathode ray tube, the charge by mass ratio remains same irrespective of what gas you are using. But in this case, it is different. That means these rays do not contain a fundamental particle unless and until you are using hydrogen, but that contains a fundamental particle. And later some more studies were done where actually you found out that these particles were much more heavier than the cathode ray particles. So if I go back, I'll go back to that slide. So at a higher level, if you want to understand electrons, and by now we know protons. Where are we? We are somewhere in 1918 now. First World War has ended. First World War is from 14 to 17. We are in 1918s. Electron, proton, negatively charged particles, positively charged particles. And the concept that was known as that both of them exist in the atom, and therefore they make the atom electrically neutral. Means if an atom exists electrically neutral, then electrons and protons must be there, and the count must also match. Yes or no? Count must match, right? Then came, what about the charge? They were actually found to have the same magnitude of charge, but the polarity of the charge was different. Okay, when you study about charge, the SI unit of charge is Coulomb. Coulomb is named after the scientist Coulomb, denoted by the word capital C. The charge of an electron is 1.6 into 10 to the power minus 19 Coulomb. The charge of a proton is also 1.6 into 10 to the power minus. However, this fellow is associated with a negative charge, this fellow with a positive charge, right? Then we come, this is the charge aspect. Then comes the topic of mass. So we say an electron, relatively, an electron's mass is 1 by 1840 times the mass of a proton. So just understand how light the electron can be. Electron is 1/10, no, 100, no, 1000, no, almost 1 by 2000 of the mass of a proton. The mass of a proton is around 9.1 into 10 to the power minus 27, no, 1.6. This is 9.1 into 10 to the power minus 31 kg. That is 1.6 into 10 to the power minus 27. Anyways, that's not so relevant for you. You should know that the mass of an electron is much less, right? So now go back yourself like J.J. Thomson. Now you know that the atom is electrically neutral. The atom contains positively charged particles called protons, and the atom contains the negatively charged particles called electrons. Is this understood? Right, fine. So now we go back. Then he has to give a, this is known as the Thomson's model. Model of atom. From here starts the interesting story. First, Thomson will give a model of atom. This model will be discarded, thrown into dustbin by Rutherford's model. Rutherford's model will be thrown into dustbin by Bohr's model. Bohr's model will be thrown into dustbin by Schrodinger's model. And that is the model, the quantum model, that we still study. Many things which are not known to us till date. Is this understood? Okay, now what is the Thomson's model? Okay, Thomson's model says that the atom can be compared like a sliced off portion of a watermelon. So what do you see? Red in color. So he says that the majority of the atom is a positively charged space. So the red color is compared to positive charge. Have you understood? Uniformly spread uniformly spread, and the electrons, okay, and the electrons are embedded. These are electrons embedded like the seeds. Have you understood? Electrons are embedded like the seeds. This was his model. More than that model, the name that we more know is the plum and the pudding model. So he said that the atom has this, the majority of the atom is like a pudding, yeah, and the pudding is the positively charged sphere. See, if any Indian would have done them, we would have called it the Kalakand and the Badam model. The atom is a 3D model of a Kalakand with pieces of Badam embedded on it. And the Badams are what? The electrons. So here we had and then we had small chunks of plum. These are the plum chunks. And these represent the electron. This is there in your course. You should know. What is J.J. Thomson's model of an atom? J.J. Thomson first discovered electron. Then he had the intuition that for the atom to be electrically neutral, there must be proton. So if there are electron and proton, what is the concept? What do you say is the structure of an atom? So the structure was actually known by models. So the Thomson model describes the atom to be a uniformly charged positive sphere, like a pudding. And chunks of plums which are spread on a pudding are like the electrons which are embedded on it. Or you can think it like to be a cutout portion of a what? Watermelon, where the red portion represents the entire positively charged portion, and the seeds are embedded into it, which are the electrons, and the count is matching with each other. Story so far. Any questions? Okay. Then samay beetta gaya. We went on. So then comes another person. Yeah. Write down. I'll wait. Okay. Then time went on. So by that time, there was a lot of advancement. And then comes one person, and his name is Ernst Rutherford. He is a Kiwi, New Zealander. Time is around 1934. Yeah, 1932, 32, 34. 32, Chadwick discovers neutrons. 1 minute, huh? 1 minute. 32 is Chadwick that I know. Oh no, it's 11. So I'm sorry. Huh? This is 1911. 1 minute. 1911. So by 1918, proton word was coined. So there's a catch here also. This happened before the... No, not this happened. The concept of having a positive charge inside the inside an atom was always there with J.J. Thomson. So he had conceptualized his model with a positively charged. So he said that the positive charge is uniformly spread. But coining the positive charge to a particle called proton, that word proton was coined way back in 1917 or 1918. But the positively charged particles were present. Now this is Rutherford's model in 11. Now here you have to understand, Ernst Rutherford was actually a big time rich man in those days who had a radioactive company, something like how we have Ambani company nowadays. He was a very rich person. And he had a lot of good, talented, scientists and engineers, out of which there are 2 engineers. The entire this experiment is attributed to him. It was his company. But the two guys who actually does in his company are two fellows named as Giger and Marsden. Giger, Giger and Marsden. So the Giger and Marsden has done diffraction, then lot of experiments. He is the only person from New Zealand who holds a Nobel Prize, and he had a very short-lived life. He died at the age of 40, I think. Okay, 40 or 44, he died. So Ernst Rutherford is attributed to the discovery of nucleus. He is attributed to the discovery of nucleus. Now, nowadays, you know that nucleus has got nucleons. Nucleons contains what? Protons and neutrons. Abhi neutron ka lekin baat hi nahi hua hai. Okay, time is very less. So I will not go to his experiment. I'll just tell this experiment, after which the nucleus came. His experiment gave what was known as the Rutherford's model. And this is also known as the planetary model. Planetary model. And this model is the aftercome of a famous experiment called the gold leaf experiment. Gold leaf or gold foil experiment. This entire experiment was actually done and set up by Giger and Marsden. It is there. We only read the good part of it, that is cool. But before this, some more interesting stories. See how fast was the advancement of science in those days. 1897, you got to know about electron. By 1911, you coined something called nucleus. In 1932, James Chadwick discovers neutron. In 1945, Hiroshima and Nagasaki are bombed by atom bomb, which is done by high-speed nucleus only, neutrons only. The same neutrons will bomb in a plutonium isotope. So just see the advancement. In 1911, you just got to know about nucleus. And by 1945, you have bombed also 2 cities using the same atomic power. World was on a crazy race at that time. And this